Hello again. As you can see, I'm actually in a new project today. Uh, it's not assembly. What gives? I don't know. I wanted to try something different. I still have the project in assembly. Yeah, as you can see here, I have some troubles or some problems. I always say troubles. Nice. You can see it's because I have two kind of struct declarations. I have a point, which is just an x and a y, and then I have a line which are 2 points. And currently, there's something wrong with the type checker, or the type stuff. So yeah, it doesn't really know what point is, I guess. And yeah, I don't know yet. And I honestly didn't even wanna bother with it because, anyway, I have proven now that I'm quite sufficient in assembly, I guess, and it's actually quite fun to program in assembly. I can really recommend it. It's quite fun, and you get quite good at it. Oh my god, what's going on here? So anyway, I started the new project. You can see there's not a lot in here. I started it yesterday night when I got home from work. Yeah. So it's kind of the same. So just like port it to C instead. I'm using some features from the new C standard. I think they're from the new C standard. At least I saw a video where they talked about it. I will talk about them when I get to there. So anyway, it's basically just a mapping from assembly to C, and when you already have done it in assembly prior, it's really easy just to do it in the C, because assembly and C is not that far from each other. However, like, I'm almost at the same point as I was in assembly, just because I have already done it like last week. I programmed the program in assembly last week, so it's not that difficult to just port it over to C. And yeah, and well, C is just a strong language. It's I don't know, some people think it's a low-level language. I actually don't feel that way anymore. Like, you get a whole new perspective once you have worked with assembly. So it's just a totally different experience. I actually think this is very high level. Like, you have a bunch of nice features. So yeah, that's nice. Hold on 2 seconds. All right. I just got invited to the city, so I'm going to have to make this quick. So anyway, I'll just do a quick walkthrough of how the program works. So you can see here I have some input, and it's just like last time in assembly, because I didn't want to bother with reading from a file. But right, you saw how easy it was to read from a file. You just use mmap, and you have basically the same. So I have this lexer here. I can just show you. Oh, not this one. This one. I have a lexer. It has a bunch of stuff, and there's also some stuff that I haven't gotten to implement yet. But it will be later on. Yeah. So it has some stuff. It has a token queue. Like, if you remember from my assembly stuff, you have a peak token and a current token. So basically, if you want to pass something, you need a look ahead of at least one. You can have more if you want, so that's why I have up here. You can have 3, 5, 10, but you don't really need any more than 2. If you at least stay inside allow 1 languages. and LL1. And if you don't know what that means, you don't need to know it. It's just some fancy academia shit. You don't need to know it. Anyways, so it has a bunch of fields. File start, so basically the address of this f, basically, and then onwards, and current position, which is the pointer. So the pointer will like progress while we read each token. And oh yeah, these are the indexes into this queue, token queue, or like it's not a queue, it's like a buffer, where you can like the current and the peak token. And then you have some line stuff, so it will count how many new lines you encounter, so you can like do pretty printing and like show nice error messages. Like I tried to do error messages in assembly, but it's very difficult because, well, you can, it's just, there's a lot of extra metadata, so, and that's difficult to implement, or it's not difficult to implement, it's bloating the pure assembly functionality. Like I know that error handling and error messages are part of the compiler, but sometimes you just want to compile it. So anyway, the lexer and the parser is kind of intertwined, just like last time. So if we go into the parser file, this is the parser. You can see this is the first function I call, and it just calls, like in assembly, next token. And this is this huge file. Look at it. Oh my god. 270 lines. Enormous. And it just like goes through. First we delete all the white space. The same trick as last time, like if the current character value is less than 32, we just skip it. And then we just like look at the current value. If it's either one of these, like one thing, we can just instantly say it's this one and then just return. There are some with, for example, equals. So if we stumble upon an equals, and if the next character is also an equals sign, then we are actually in double equals, I guess. You can see that here, double equal. Yeah, so it's kind of like a hacky way. You could also like implement them down here, but yeah, you already like handle the case up here, so there's no reason not to do it. So we can see here, when we find a match, we set some left and right values, and these left and right values are, for example, for this identifier, for example, the left is this point and then the right is this point, so it marks where we can find it in the input string. So this is basically like useful for error messages. Yeah, so that's the left and the right, and then on the line, that's kind of self-evident, and then we have some token types. Whoops, that's in the token file. We can see we have a bunch of tokens. We have the end of parse, let, function, left parent, curly, bracket, colon, double colon, semicolon, comma, dot, and so on. And then we also have some node stuffs down here. And I'm adding to this, so if I miss something, I just like boop, another one. But yeah, we don't really want that. Not that one at least. So you can just see we have a bunch of tokens. These are the different kinds of like leaf tokens in our abstract syntax tree, and then these are the inner nodes. And you can, if you remember, or if you are fast, you probably recognize that we only have two, the current token and the peak token, and how can we like build a tired tree with just two? And that's because we just copy the information we need onto these nodes down here, and if there's any data we don't want, we just discard it. And I also have some primitive types, and I like the idea of being very explicit with how much you have, because I don't really like the abstraction stuff. Because in C, do you know what 64 bits integer are? Like, for some reason they're called long. Like, that's just stupid. I don't know why, but yeah, it's just dumb. So that's the kind of like different token types you can have. And then we have like a struct token, which are the leaves, and these have one of these enums up here, like the token type, and then they have a literal type. They might have, they might not have, and I actually think I will delete this because I already have them here. And these literal types are only in the inner nodes. Like the Lexer is not context aware, so it doesn't really know what is the type of this, what is the type of this. It just knows this is a string, this is a float, this is a integer, and stuff like that, right? So I actually think I will delete this later. Nice. Yeah. You see they have the fields, and I use a union, so it's kind of like C's version of inheritance, I guess, maybe. It's not really, it's just how you can build or like polymorphism, right? Because this token can have either an enum or a fnum or a string or a node. Like it can have a bunch of different things. And I don't even know if I use this node. It's just you develop stuff and then you progress and then you think you'll want it, but then you don't want it and stuff. Okay, whatever. And I have a bunch of different stuff here. It's just like an assembly where we have the constructors. You can make a new function declaration where I had a function called construct function decl node and stuff like that, and then you have to push all the arguments into the stuff. But you know, C is very handsome because it just does it for you. Like right here, function declaration. So we tell C is this type, struct declaration function, this stuff, and then we can just like give it the parameters, and then it just fills it out. Very easy. Yeah, and all of these you can see they're very shallow, and that's on purpose because you just want to minimize the surface area of these, because then you just have a single node which stores a bunch of these. Like it can store one of each, and that way we only have to care about one type, its node, and it has some content, which is either a function declaration, variable declaration, array declaration, assignment, and so on, right? Yeah. Just like type polymorphism. Very nice. And you can see I had copied over the line left and right, also for like pretty printing errors and stuff. And that's basically it for the tokens and the nodes. So remember, you assemble tokens into nodes, and then you assemble nodes into other nodes. So like a binary node, the left node can be another binary node. It probably won't, but the right node can be a binary node. Oh, the left node can also be a binary node or binary operation, and then it's just like and you can see like some of these actually are very similar, and I might actually just remove these types because you can give them names down here, so you don't even need a difference like field access and compound statement, for example. You can see they have the exact same types. The only difference is the variables inside it. So this is even left hand side, right hand side, and left and right, so they can actually be merged together to one, but I will do that later. Yeah, so when you first call parse, you just like call next token, so you actually have the first token in your peak, Um, excuse me, I think this song is very distracting right now. There we go. So you want to pull the first token into your peak, and then you can start parsing. Otherwise, it's just like filled with 0 or nothing in both current token and peak token. So you have to like start parsing or lexing, I guess, maybe tokenizing. And you can see I have a very like shallow implementation of this top level statements, and that's just to like get started, I guess. And I don't even know what else is a top level stuff. Like you can have a function declaration, maybe some global variables. That could be nice. So let statements. So top level stuff, and then you can pass a declaration. If you find a fn, then that's a function declaration. And then we go into here, and you can see I pass the struct parameter all the time. And then you just call next token, and then this is my way of error handling. It's an assertion. It's defined in this assert token type. So it's actually a macro. And I got this from a YouTube video. It's a very good video. It's also kind of long. They talked about the new standard C23. Very nice stuff. So these are like the parameters for it, so lexer, and then these are actually struct fields inside it. So you can see here it's a struct assert token type, which is this one. And then you can just like say, it's kind of like named arguments or whatever. So you can say dot expected token, which is this one, and then you can say which. Oh, that's this one. And then you can say dot error string, this one. Oh, nice. And I have done the same with the string. Here. So you can just, like, if I wanted, I could like place this after, like here, and it wouldn't complain if the parentheses here were correct, but they aren't right now. Yeah, so that's some of the new stuff. I think it's the new stuff. He talked about it at least. If it's not, then who cares? It works. It's very nice. And then you just go through them. So like, is the current token an identifier? If it's not, it's going to error out and it's going to print an error. And we can like see it in action if we want. So I can like say, let's say we do a keyword instead. So like let is a keyword. Then we can say, oh my god, oh, clang here, nice. A.out. Then you see here, int mem.say is just because it's just a random name I gave it. Line 1. And then it says error, unexpected token, expected function name. And it says actual, like what it found was a let token instead. And that's correct. Yeah, and then it exits. So, like, okay, my compiler only finds one error at a time, and that's deliberate because like normal compilers are like very bad at. Have you ever like had some errors and a bunch of them were just like garbage errors or like phantom errors, so not real errors? Yeah, that's why. So anyway, you just like go through them. Then I want a left parent, right parent. Oh, insert the parameter list here, of course, for arguments, like, right? And pass statement, which is the body. it's basically just the same. So yeah, pass statement, switch. What do we find? We find a lit, because that's the only statement I have. You can also say maybe it's an identifier, so an assignment, and then we just pass an assignment. But now I have only implemented declarations. And this is actually kind of neat, because let's see here. This is the first statement, right? On here to the right. So when we first get in here, we say, we switch on the type, and if it's a let token, so this token, then we pass that declaration. Once this statement is done, that means when we have reached this point, it's going to break out, and then it's going to try and pass another statement. So it recurses and calls itself, and then we move the semicolon into our current. No, I'm sorry. We move the let statement into our current, and then we switch on it again, and then we see it's a let, another let statement. So we get here, and then we get here, and we pass this entire declaration. We return, we break out of the switch statement, boom, down here, and then we try a pass again. The third time we call this function, it's going to pull in the next token, which is this token. However, now we don't match on anything, and then we're just going to return null. Then we are going to pop return here, and we are here for the second time. So after we try to pass something after this, and then it's going to be null, so we're just going to return the first statement, so this statement. Then the first time when I called it on this let statement, this right hand side statement is going to return this declaration, or whatever is going to get returned in here. And then we have to like construct a compound statement, and in my assembly I called it a statement list, but it's not really a list, it's just like two statements concatenated, so let's just call them compounded instead. Yeah, so we get a new node, and then we just like push them inside it, and we return the compound node, and that's how we like can make this infinite. Like I could probably like do this if I could copy correctly. Like this maybe. It's actually, let's see if it works. It does. Very nice. When it doesn't say anything, it's okay. It's just like any command. If it doesn't say anything, it works. Like the compile stuff. Yeah. And then again, the declaration, like I tried to make it easy to understand what could go on. Like you can make just like this, another variable type int, and then you can do a kind of like a declaration and an assignment at the same time. So like it's going to look like this. Let SDF be of type int and be 69. Like that's the second one for this one. Let identifier SDF colon another identifier equals expression, which is 69. You can also like do -3, whatever. The third one is this one. So basically like an array, we want 2 of whatever type is on the right. And then this statement is kind of like an alias. So you can like say let my string be of type 10 U8 or I8, whatever, maybe U8, right? So like you can make your own type aliases or whatever. So, and actually that's not correct. This wouldn't work. No, it wouldn't. I want to make this, but that's not what it is right now. I guess you could like do. Okay, so you know one character is 8 bytes. You can like say my U64 to like have 4 characters in one. Yeah, I don't know. This is just an alias. I thought that would be cool to have. And then the last one is just like a struct. I haven't implemented it yet. Yeah. Yeah. And you can see it's just basically filling it out. And the parse expression is just the same. So we have the top level expression, then we have some comparisons like equals. And you might ask yourself, why would I go into the trouble of like doing all this recursion? Like this function calls this, and this calls this, and this calls this. It's to make precedence correct. Like, you know, when you do recursion, the stuff you call, it's like kind of like a first in, last out. So the stuff you first see is what you're going to delay. That's a very bad explanation, I guess. Anyway, trust me, this works. Yeah. And that's it, basically. And this is basically my get empty node. So like, I don't heap allocate at all. I just use kind of like an arena allocator. For now it's just stupid. I use realloc, so I try to make it twice as big as it was before, if we go out of size. And if it fails, we just exit out of memory. There's nothing we can do. We can't compile anymore. If you don't have any memory, like, get a better computer. Or maybe split up your files. Yeah, otherwise you just return the next one in the stack, or the next free one. So we get a very nice cache coherence. And I have embedded all of this inside the Lexer. As you can see here, token queue, the string store, and the buffer is actually not inside it. I should probably do that. I should probably push this into the Lexer. Why would I want to do this? Basically because then you can have multiple Lexers lexing different files. That's an easy way to like parallelize it. Because the Lexer is just what hosts the entire state of the program. You should probably just like pass in some state, call it state instead of Lexer. I should probably call it state, or like context maybe. Like anyway, I might develop further on my assembly, but right now I'm just enjoying the niceness of C. I actually kinda very much enjoy it. It's much better than Java. No boilerplate, it's just high level assembly. That's how I see it. Anyway, until next time. I can just show you my Arch, by the way. Anyway, adios.